All right, folks, so looking at number 5, last problem of Unit 8. In parts of the U.S., wolves are being reintroduced, to wilderness areas where they had become extinct. In 2010, there were only 46 wolves in northern Michigan. That year, 20 wolves were released in the same area with an estimated yearly growth factor for the population of 1.2. Growth factor is a fancy way of saying we already did the 1 plus R stuff. So 1.2 represents 1 plus R. So that would mean our R is 0.2. So what percent are the wolves growing by? 20%. You can draw a little cloud around that stuff. That's just extra. But if you are given the growth factor instead of a percentage, you don't have to do the 1 plus R. You don't have to figure out what the R is because the 1 plus R is already given to you. So it says write an equation to model the situation. So we've got y equals A times 1 plus R raised to the t. Well, we're going to have y open for input. Our initial amount, or our A, it's in 2010. That's going to be our time 0. And it's like there were 46 wolves, but then they also added 20 wolves. So in that year, the starting amount was 66 wolves. The growth factor, we just get a straight up, right, 1.2. So that's your 1 plus R already taken care of. And then raised to the t. We're going to add something to part B because it says calculate how long it will take for the population of the wolves in North Michigan to reach 300. We want to find how long, which means we're looking for T, but I also want you to calculate when. Now, if it's like, wait, what's the difference between those two? How long versus when? How long is years since 2010 versus when is going to be the actual year? So let's go ahead and see what we can do with this problem. We want to know how long it's going to take for the population to reach 300. So we're going to put 300 in for the Y. Equals 66, 1.2 raised to the t. We've got an exponential equation, boop, because that's where our variable is. So first, we want to isolate the bases to see if we can get the same base. So we're going to isolate the base that has the exponent with it by dividing by 66. Now, 300 divided by 66, yeesh. We don't want to round it because rounding on rounding on rounding leads to less exact answers. So because that comes out so grossly, we're just going to roll with the fraction for right now. So, all right, 300 over 66. Great. Happy Monday. So 300 over 66. 1.2 to the t. So what do you think? Can we rewrite 300 over 66 as base 1.2? They're both disgusting. No, we can't write them as each other. So what are we going to do to both sides? We're going to log both sides. So the 300 over 66 is inside that log. And then the log of 1.2 raised to the t is in the other log. And what having that log allows me to do is move that t out in front as a coefficient. And I'm going to be a little bit lazy here and just write that t at ground level and then divide by log of 1.2 in one fell swoop. And I want everybody to type that in on your calculator. Make sure you close off your parentheses in the right spots. And let's round to the nearest year. Should have gotten t is about 8 years. So that's how long it will take for the population of wolves to get up to 300. But as far as when, if time 0, or our initial time, is 2010, 8 years from 2010 would be 2018. So we add 2010, and the when, part C, would be in the year 2018. And that concludes Unit 8. So folks, our game plan for tomorrow is we will be taking the homework quiz over 8.2, but we're going to do some hefty review before we do that as far as what type of equation is this? What's our plan of attack? Can we get the same basis? Do we have to log both sides? Do we put it in exponential form? So we'll do that, take the homework quiz, and then it's going to be time to work on the review. What I would like to do next is go over some of the problems that folks weren't here for yesterday and some of the questions that I have gotten since. So I'd like you to, in your homework packet, first turn to page 6. And you should now be able to do numbers 50 through 58. Those aren't due until tomorrow night, but what else is going to be due tomorrow night? The review. So I would try to haul on this a little bit today, since we are going to have a sizable chunk of work time. You got a little more than a half hour to be working on these. They shouldn't take too long. It's just figuring out what equation to use and what variables go where. But I do want to go down to number 53. And it says, how much will my investment be worth if interest is compounded annually, quarterly, monthly, and daily? So we want to figure out what n is for each of these. For annually, n is 1. Quarterly, how many times per year is that? 4. Monthly, 12. And then daily, 365. Now, this is your rate. There's your initial amount of money that you invest. So R is 0.036. And we do this for 4 years. So we want to know how much money, A, will we have when it's compounded this way, this way, this way, and that way. So I do want to go through this together because, well, at least the first two, because I did have some questions in the last block on this. So let's start with that equation for compound interest. A equals P times 1 plus R over N raised to the NT. And again, older calculators, those parentheses. So A is what we're looking for, that starting amount, or sorry, that final amount in the account. And it will be $4,500 for all of these. So actually, let's go ahead and write the skeletal structure of all these. A is $4,500. A equals 4,500. Because the principal is going to be the same for all of these. What else is going to be the same is 1 plus the rate, 0.036. 1 plus 0.036. 1 plus 0.036. 1 plus 0.036. What's going to change for each of these is the n. N is 1 divided by 1 raised to the 1. Quarterly, n is 4 divided by 4 raised to the 4th. Monthly, divide by 12, raise it to the 12th. Daily, divide by 365, take it to 365. But then don't forget, we have to multiply by t up with that exponent as well. And the t is 4 for all of these. So times 4, times 4, times 4, times 4. So the only thing that is changing is how often the interest gets compounded. The more often it's compounded, the more interest you are going to get. So we're going to start typing these in on our calculator to see what the final amount is for each of these. So 4,500 times 1 plus 0.036, raised to the 1 times 4. Rounding to the nearest hundredth place, since it's money. A is $5,183.84. Now, if we get our interest calculated 4 times a year, that's going to be more money coming our way. So the interest should go up. So this amount should be slightly higher when it's compounded 4 times. So 4 times 4 and divided by 4. We're changing the n number. So 5,193.63. So I will leave you guys to finish the monthly and the daily. Just realize that it should be going up each time. So I'll leave that up there for a second. Folks who were gone on Friday, I'm sorry that I didn't have a video made on the problems that we covered as a class. So I do want to kind of quickly discuss some of those problems now. The scan is uploaded so you can see the walkthrough of those problems as you work through them. But I did want to talk through some of the problems that I had a lot of questions on. So first, number 43. On number 43, we have 2 logs. We can't cross them off right away though because they're not completely corresponding because this one has a coefficient in front. So we first take that coefficient to the clouds, then we can cross off that natural log with that natural log, corresponding parts. We FOIL, our favorite thing ever. X minus 3 times x minus 3 is this. Then we get a quadratic, and that quadratic cannot be factored. Folks, nowhere in this chapter am I going to make you use the quadratic formula, so you can cross off number 43. Not doing it. So if you encounter an unfactorable quadratic, that means you either goof somewhere or maybe you need a little bit of help with doing the factoring. The other problems that we covered were number 48 and 49. So on 48, we've got two logs, but they are on the same side of the equation. So I don't get to cross off corresponding parts because that has to be one side equal to the other side. These are not corresponding because they're on the same side. And I can't just move this one over to the other side because I've got that awkward one just hanging out. So when I have two logs on the same side, we condense them together. Now these two logs are separated by subtraction, so we would have to condense them by dividing the answer parts. From there, once we have one log, I asked third block what to do and they said log both sides. You only do that when you are solving an exponential, so I can't cross off the log, I can't log both sides. What do we do when we have a one log expression? We put it in exponential form with big animal ears. So big animal ears. That gives me 2 to the first equals that business. Now when you look at that business, it's like, oh yuck, we have a fraction. How did we get rid of fractions in the past? We multiplied through both sides by the denominator. And that takes me to a quadratic, not forgetting to distribute that 2 to both of those. It gives me a quadratic. I moved everybody over to the right side in order to be able to factor.
Read Atkinson is going to be attendance office.
It seems like it's going to be prime, but actually it does work out. Yeah, 1 and 17 are the numbers that work there. And then we do all this work. We get x equals 1. We get x is negative 17 halves. And what happens is when we plug those into the answer part of the log, they both give us something negative. Now this is important because is 1 itself a negative number? No. So it's not about the solution being greater than 0. It's all about what it does in the answer part of the log. So all that work and it ends up being no solution. Folks who are gone, I do want you to work through this problem, but now you have my video explanation and me talking through it right now. And this is also uploaded on Canvas on Friday's agenda, the scan of this. On number 49, a similar problem to the one above where we can't condense when we have coefficients out in front, so we would have to send those to the clouds first. So 8 to the third, 36 to the 1/2. 36 to the 1/2 is the square root of 36, or 6. 8 to the third is 512, and because these two logs are separated by subtraction, we condense them by dividing. Now, once I get to this point, unlike this problem where I had one log equal to 1, which requires exponential form, when I have a log on each side, that's when I get to cross off the corresponding parts. Now, some folks actually divided that on their calculator and wrote the decimal answer. Totally fine with that. You can leave it as a fraction if you want, or you can round it to 2 decimal places. So those were the problems that we covered in class on Friday. And now I'm just going to give you guys time to work, time to ask me questions, to get you ready for our review day tomorrow. So let's stop the video.